Okay, so we're going to do the second part of this problem now. We just finished the first part and realized that the airplane's not going to be able to take off. It's not going to reach its takeoff speed by the time it gets to the runway. So we're going to want to figure out what the minimum length of the runway has to be then. So here goes the rest of this video.
Is if not, what is the minimum length the runway must have? What is the minimum length that the runway must have? Now, I'm not going to make you redraw all of this because of the next question, because we can use a lot of this as part of our information. The only thing that I'm going to change is that I know that my X is not going to be 150 meters anymore. It's going to be longer than that, right? So I'm going to cross that out. And I don't have that value, and that's what I need. I need the actual X value now. So that's what I'm going to try and find, right? I'm going to try and find that X value. Okay. And what do I need to do to accomplish that? I still don't have time, so whatever I do, it's going to have to involve v squared equals v0 squared plus 2a times x minus x0. Okay, and so again, my initial velocity is 0, my initial position is 0, so I've got v squared equals 2ax, but now I'm not trying to find the final velocity. Now I'm trying to find the distance that I'm going to go if my final velocity, and I'm going to need to put that down here, my final velocity is now going to be 24.5 meters per second. So what we're saying is, okay, I can't reach that velocity after 150 meters. My final velocity is going to be, oh, wait a minute, it's not going to be that either, is it? My final velocity needs to be 27.8 meters per second. Okay, this is my final velocity at 150 meters. My final velocity at the point I take off needs to be 27.8 meters per second. Okay, so that's my new final velocity. But I want x. I don't want v. So now what I'm going to do is divide both sides of this by 2a. That's going to cancel out. And so now I have x equals v squared over 2a. So I've isolated x, and now I can just plug those values in and solve. X equals, my velocity squared is 27.8 meters per second, and that's going to be over 2 times 2.00 meters per second squared, and that's going to equal, let me see here, 193.2. I had to go find out what it was. It's going to equal 193.2 meters. Okay, so this is where we're at, and let me just show you about the units again. So I'm going to square meters per second. So if I square meters per second, I'm going to end up with meters squared per second squared, right? And then I'm going to divide by meters per second squared. The second squares are going to cancel out, and 1 meter is going to cancel out there, and that's going to leave me with meters, which is what I want, right? That's my distance. Okay, so this is how we're going to solve this first problem. We did not need to know a single thing about how to solve this problem. Even when it came to finding out what formulas we're going to use, all we did was ask the question, do I have time or do I need time? And the answer was no for both of these, and that automatically meant I had to use that last formula. Okay, so go on to the next problem.
Okay, so we'll go on to this next problem here.
Okay, so here's this problem. How long does it take a car to cross a 30-meter wide intersection after the light turns green? The car accelerates from rest at a constant 2.00 meters per second. Okay, I'm going to say I don't know how to solve this problem, but I do know a strategy that will lead me through this if I let it. I'm going to start with that strategy and draw a motion diagram to collect all my information on. Okay, so my origin and my direction of positive x values, and I'm going to ask what's my initial position. As it happens many times, it's going to be 0 meters because I'm told that I don't have an initial position, so I'm free to set my own. If I go 30 meters, my final position is going to be 30 meters. Okay, my initial velocity, I start at rest, so I'm going to be at 0 meters per second. And I don't know what my final velocity is. I haven't been told that. But I do know that I'm going to do this. Okay? I'm going to increase in velocity. So I know that my acceleration arrow is also going to be in the positive direction, the direction of increasing velocity arrows. And I've been told that I accelerate at 2.00 meters per second squared. Okay? There's nothing here other than collecting information. I didn't have to know any problem-solving strategy. I didn't have to discern anything. I just got the information. And now I'm going to write that down in a standardized way, given x0 equals 0 meters, x equals 30.0 meters. That's my final position. My initial velocity 0 meters per second. I don't know what my final velocity is, so I'm not going to write that down. I know that acceleration is 2.00 meters per second squared. Now in this case I don't have time, but I do want time. Okay, so my need is going to be t. So I can't use that last formula. My first question is, do I have time or do I need time? And if I say yes, then I can't use that last formula. My second question is, do I have an acceleration or a constant velocity? And I don't have a constant velocity, so I also can't use x equals x0 or x equals x0 plus vt, right? But I can use this third equation because I don't have a final velocity, so that means I have to use x equals x0 plus v0 times time plus 1/2 at squared. Now, I know by inspecting that my initial position is 0 and my initial velocity is 0, so 0 times time is still just going to be 0. So both of those drop out, and that leaves me with x equals 1/2 at squared. Well, I want t, so I'm going to isolate that first, and then I'm going to solve. So I'm going to multiply both sides of the equation by 2. That'll give me 2x equals at squared, and then I would divide by a, and that would give me 2x over a equals t squared, and then I'm going to take the square root of that. So I know that t equals the square root of 2x over a. Then I'm going to write solve. And I'm going to say t equals, and I'll put my values in, 2 times 30.0 meters. Okay, let's make that a better m. Divided by my acceleration, which is 2.0 meters per second squared. And time will now be, and those 2's will cancel out, and so I'll have the square root of 30. And that will give me 5 5.48 seconds. Okay, and that solves that problem. Okay, again, notice I did not have to do anything in the way of thinking. I just followed this process. I collected my information on the motion diagram, x0, x, v0, v, a, and I wrote it down in a standard form here, and then I said, oh, I need time, and then I asked my question, do I have time or do I need time? Yes, I can't use that last formula. If I got an acceleration or a constant velocity, I've got an acceleration, I can't use that first formula either. And do I have a final velocity? No, I don't have a final velocity. This is the formula I have to use. And I just plugged the values in and solved it. Okay, there was no thinking required. So let's move on.
Okay, so I'm going to stop this video. If I do the next problem, we'll run out of time. So we'll have one more video here to show this last problem, and it won't be a very long video. Okay, so we'll stop this one. Go to the next one.